Everybody, it's Tyler here at Riverbots High School, checking in 839Z Caution Tape Zoom. We've had our eyes on this team for a while with their great performances. Last year coming in, looked awesome, division finalists, had some great signature event performances, and this year as well too, a phenomenal looking machine. We're going to be talking about some, maybe a couple different things on this robot that you haven't heard before in these discussions, like their weight distribution and balancing and how they're approaching that. Talking about different iterations as they get here, future plans as well too, and some robot breakdowns, and going a little bit more into their CAD. So let's learn more about this team coming up here on Pits and Parts. Justin, let's talk about some of the general philosophy and design work that 839Z does for this. I mean, you guys make absolutely gorgeous robots as you come through. So talk to me more about some of that background into it, and we'll be talking a little bit more about your CAD work too.
Yeah, so our general philosophy for this robot was to build like the cleanest and most lightweight and effective robot in the shortest amount of time. So this robot was actually an RI5D, and one of the reasons why we were able to build this robot so quickly but still have it very effective in tune is our CAD first approach. So before building this robot, we actually have the entire bot CAD'd out using Fusion 360, and this allows us to, first of all, plan out geometry and also CAD out a lot of custom Delrin parts, so it's really helped with our weight saving as well. So we use a CNC machine to actually cut custom Delrin braces, and this really helps with our structure while also keeping it lightweight. So for example, one of the really interesting braces we have on our robot is for our Lady Brown structure, and this actually takes advantage of the structure of the motor and it goes around it. So if the Lady Brown structure were to bend, it would have to bend the whole motor, which is a really structural piece of our robot. And I think James can talk more about like our CAD first, how we do it.
So basically for our CAD first approach, we normally try to use like the engineering design process, and we'll try to brainstorm all our problems and then find out and also do our background research on what type of solutions that we will have. And then CAD is basically our brainstorming area where we can film out all our designs and how our bot will generically look like.
So looking at from CAD work on it, do you do any sort of like actual structural testing or stress testing in Fusion 360 at all, like before you actually manufacture it?
Fusion 360 itself has a simulation function, but unfortunately there's not much of a test that we can do for it since it requires like a specific type of material that we can do.
Fair enough. Jumping on here, you've gone through a lot of different iterations, so talk to me about what maybe some of your prior designs look like and why did you move away from them?
Yeah, so our Gen 1 design, our robot was almost 18 pounds. So at the start of the season, we noticed that the matches were kind of like slow pace, try to score as many rings as possible, just like precisiveness. But as the season moved on, we noticed that like the matches started getting like higher pace, like you want to rush around the field to steal like a mobile goal, or you want to like hurry and defend a wall stake. So our old robot was around 18.5 pounds. And at the start of the season, we thought of doing that to like help to make us not be easily pushed around. So we were able to like score wall stakes without like being disrupted, or we were like be able to like precisely score on the mobile goal. But as the season moved on, we wanted to get more high pace. We wanted to move around the field easier. We wanted to like steal mobile goals, to get our matches like scores more close. So we decided to move to our Gen 2 design. This is 10.5 pounds. So like it's easier to maneuver. So it's easier to maneuver around the field, and like it's just simpler for like driving and like that's about it.
Daniel, on here, when we look at future plans for your robot, I'd love to hear more about that. But one of the things when we talked earlier is that your team has really paid a lot of attention to weight distribution. We just heard that your design too is a lot lighter than the other one. And something we don't really talk with a lot of X teams is just overall your CG and trying to get that right. So talk to me more about how your team has approached that.
Yeah, of course. So what we actually did, Joven mentioned how it was 10.5 pounds during our second day of building, but we realized that a lot of teams, because of having such a light robot, their odometry would over-center after they make any sudden movements like stopping or driving too fast, as they would tip over due to their lighter weight. So their odometry would over-center and get them caught and and stop them from being able to drive. Some other things that we did by controlling the weight is like adding spacers and using aluminum nuts, which are much lighter than the steel nuts. We also use these half-cut L-beams, as what really makes L-beams like a lot weaker than C-channels is the divots inside, but by cutting straight down, we kind of remove those divots so that it's a lot stronger. And going into future events, we want to save weight and make it as light as possible because we're going to be going into a tier 3 design. As you can see here, we already have everything pre-planned out in our intake ramp. Here there are holes for our PTO so that we can connect to our Lady Brown and be able to hang from the corner.
Yeah, and then another major consideration with going this light of a robot is obviously tipping, right? Since we have a mobile goal that's almost 4 pounds, right? No matter where we put the CG, we're gonna either tip forwards if it's like 2 forwards to balance out when we have the goal actually clamped, or backwards if it's like centered. When we have the goal clamped, we'll be back heavy. So we know that we would have that disadvantage of being tippy with a fast drive, so we actually designed around that. So we took inspiration from 9364E and spin up with their drivetrain, how they could actually ride above rings, right? So with this drivetrain, we have a lot of clearance on our actual drivetrain. These 3.25 wheels are mounted really high up, and this allows us to actually ride over these blue rings without getting stuck, which we used in like a lot of matches, and they've helped us stay maneuverable around the field.
You know, I'm actually surprised that more teams haven't gone that route as well. You know, just like it gets so cluttered, or you got, you know, rings just in wrong places, stuff like that. I love that your team has had that thought process through that as well too. You know, you mentioned Lady Brown. Let's talk more about that because you're doing something maybe a little bit different than we've heard from teams. So Matt, talk to me about you know, what you have for Lady Brown, but you're also using it for defense. I'm very interested to hear more about that.
So our Lady Brown is very versatile. We use it both for scoring at wall stakes and also for driving around in terms of defense. We can use it to tip goals really easily, and we can also use it to tip goals in positive corners so that our opponents can't get it, or tip it in negative corners so that the negative corners won't count. So can you move it all the way up? So when we bring our Lady Brown all the way out, we can use it actually as very versatile to get into the corners where even though they're defending, we can reach into there and tip the goal as well. Also, we use only one 5.5 watt motor instead of 2, and this allows us to use another one for our intake to make it faster as well. Also, on our Lady Brown, we have this screw full of spacers, and this allows the ring to stay in there a lot tighter.
So as we've been talking to some other teams out there, they may be talking about, you know, with meta evolving, that, you know, Lady Brown may be a thing of the past soon as well too. What's your team's, you know, thought process or approach? Are you looking at sticking with the Lady Brown for the future, or are there other considerations to look at?
We'll probably stick with the Lady Brown just because of how versatile it is and how easily we can use it in terms of our driving skills strategy, and also for teamwork strategy in order to give it more versatility as well.
Let's wrap up here, Jonathan. Talk to me about you know, programming side of things. I noticed you got a couple of odometry pods as well too, but what do you want to highlight from your team from that side of your robot?
All right, sure. So to build on what Daniel was talking about earlier with odometry, we actually noticed that these small 2-inch Omni wheels actually have little gaps in them. So that's why we doubled them and slightly staggered them to make sure that when we're using the rotation sensors, it's really hard for it to be inaccurate. So it's a lot more accurate when we have them double stacked for both vertical and horizontal. Yeah. And we also use color sorting when we are driving and in autonomous. So if you want to demonstrate it. So we have an optical sensor, and we actually have it here on the side, because when we have, some teams have it in the front, and sometimes the issue with the hole, it sometimes double senses it, and if it's from the side, it only senses it as one big brick, kind of, as a ring. So it allows it to be a lot more accurate with the color sensing. So, yeah. So as you can see, the intake kind of stops right before it can go into the mobile goal, and this allows us to make sure we never accidentally score for the other team.
Caution Tape Zoom, thank you so much for telling us more about your robot here. You guys have been looking phenomenal, so can't wait to see how you do here at Riverbots, but of course throughout the rest of the season as well. There's a lot of great things that I think teams maybe haven't considered that you should be considering as well too when you build your robots. So use this as a great example, build your own phenomenal machine as well. Caution Tape Zoom, thank you so much, and good luck the rest of the way.